much. Can you hear me? Yes, I think so. We want to share our ideas, our thoughts about the flexible factory of the future. And one of our ideas is to use nesting technology, autonomous technology. And we want to tell you a little bit more what does that mean. We'll start introducing AECOM, then go a little bit into the technologies that we use, that we need to use to build this flexible nesting factory, then into the autonomous process and optimizations that will Frank do, and then we will do some concluding remarks. So, who's AECOM? AECOM has more than 500 offices all over the world. We are based in more than 150 countries. We have more than 58,000 people. We had an annual revenue of 19 billion last year, and we are ranked as number 1 in the design firms for the 6th consecutive year. We are working in oil, gas and chemicals. We are working with buildings, construction, infrastructure, power, governments and industrial. So I will start with automated guided vehicles. That's essential for this flexible factory of the future. Most of you know automated guided vehicles, AGVs. They are used in supply. They are used to transport goods. They are used to transport components. They are used to transport products. They are also used as a cellular manufacturing line. They are used as a manufacturing platform, and nothing new really. But if we want to make our factory of the future really flexible, we need something more. We need autonomous technologies too. So let's just go on with the AGVs as an example. This can be transformed to every other technology, robots, equipment, and whatever you have in the factory. You need the traditional technology. You need autonomous technology. You need autonomous sensors. Transfer this into your traditional technology, and you have what you need for the factory of the future. Rather easy. One example from logistics, supply chain, how you could use this from the AGV. You get the components in with a truck, with a carrier. The truck just put on the carrier. A fully autonomous AGV picks the carrier up, brings it fully automatically into the warehouse, where it's fully automatically unloaded by AGVs, autonomous fork trucks, whatever you need. Fully automatically, the goods is brought into the factory, and other AGVs fully automatically and autonomous bring the empty carrier out, and it get picked up by the truck. The truck could be a future autonomous truck or a normal manual driven truck. And then the truck leaves with its goods. So now we go into the manufacturing, how to build the products differently using nesting technology. The future flexible factory doesn't have specified stations, doesn't have specified path. It can use swarm intelligence, it can use augmented reality, it can use self-learning systems. Every area in the factory will have its own identity and intelligence. Every platform or AGV or whatever will have its ID and intelligence. Every product will have its ID and intelligence. Every equipment will have its ID and intelligence. Every component will have its ID and intelligence, and of course the people working there will also have their ID, and I hope they are intelligent. The system will now not follow a defined path, it will organize itself. So if the system recognizes, hey, it's more effective to bring the product to the components, okay, the product is brought to the component. If the system discovers the most efficient way would be to bring the equipment to the product, okay, then it's brought to the product. Or if the system discovers the most effective way is to bring the product to the equipment, okay, then it does that. It will organize itself, and from day 1 to day 2, it will organize it different. It will always search for the most effective way to do this. Just to make a comparison with a traditional production line, known from the automotive industry, you get the car in. The first in will be the first out, and it doesn't matter what options you have, and especially the industry today, the automotive industry as other industries too, the products are getting more and more individualized. So take an example of the automotive industry. This car needs a panel roof. This one don't. This one don't. They will all go through the same stations or make an extra way around. If we use a hive, a nesting organization, it will always search for the most effective way, and it will organize itself, bring the station where it will be the most effective for this product at this time with the component that we have and the equipment that we have at the moment. And to organize this, of course, we need hyperconnectivity, and that's where Industry 4.0 and all these buzzwords come into consideration. And how we can organize this autonomous system from a process point of view will be told you from Frank. So Frank, this is yours.
Thank you. So basically, when Lars, when we were first talking, he showed me a couple of ideas, and I was like, okay, that's nice, but how do you organize this? And the organization and the process within a nesting facility is one of the most complex thing you can imagine. So basically, if you do it on an abstract way, you can think of a couple of hives down here, and there are AGVs in there, and they talk to each other. Now, if the process changes, they have to transit between the nesting stations, between the hives. And there has to be some sort of higher order AI-based, artificial intelligence-based method to steer that. But you also need a human intelligent or a human way to organize, to steer that, to make higher order strategic decisions on that. So basically, in a nesting facility, in a nesting system, you would have at least two steering processes. One is really on the steering edge, and the other one is basically around here, where you have reactive systems taking care of, okay, I have a breakdown here, I have to switch over to another nest, I have to compensate for occurrence of unforeseen. And this brought me down to the idea that you actually have multiple levels, and I'm going to just describe 4, but you can expand that to many more, of level of process complexity. And at the top, you have the human decision-making process that has to take place. You have a steering, strategic decisions that are there, and this is eventually fed into macro processes, which can be an entire line, but it can also be a station. So these station processes have to be monitored, have to be adapted based on the strategic decisions from above. Now, following on the macro processes, you have the micro processes within these cells where the AGVs, where the machines have to reorganize them, have to communicate. And this brings me to the last layer, which is the interaction between all the machines. So you have a communication flowing from top down, but up here there are a few very important strategic decisions been made, whereas here constant communication is required to adapt to ever-changing situations. Now, one way to do that, or one way to get into optimizing the processes that we currently have and that are possible with nesting is if we use data, and everyone is using data today. But actually, we're not, because if you think of a regular company, right now, they capture their data. They might even use some very smart tools and artificial intelligence, machine learning, and you call it. But in the end, if you have multiple sites, the information is not shared, knowledge is not shared. So you have an encapsulation between the sites, and sometimes emails are sent, but most of the time it's very difficult to get information from here to here. And one way to, well, the essential goal is actually to have everyone being able to access the data, to know what errors have been made here, so I can compensate here. So basically, in a broader sense, a lessons learned system. But yeah, I digress. Now, one way to do that, and there are many buzzwords involved with that, is data warehousing and data lakes, and you can call them whatever you want, where you have a central hub where all data is stored. Well, you could also argue that a way to do that would be to have some fog computing. So basically, you do the heavy lifting here and just share the valuable information and put it into a cloud or into a secure facility. But this is possible for one company. And if you have multiple sites and you can distribute the data and everyone learns from it, this is really nice. But what happens if you have multiple companies that are actually doing similar things, that have very valuable equipment that they only have once or twice, but still want to do predictive maintenance of that? They have to run the machine for years to have every special case there can be to get information out of the data. Now, some might say, okay, we just openly share our data with everyone. And I would say, don't do that, because everyone knows what you're doing, everyone will understand your processes, and it will get reverse engineered what you do. So basically, one way to think about it is if you had some sort of secure space, let us call it the encryption space, where everyone can put up their data. It's like a secret club. Everyone who wants to participate puts up their data. You can use your own data. You can see it. It's clear text to you. You cannot see the data from everyone else, but you're allowed to use it. You can have mathematical models run on that data to get you insights, but without knowing if it's from Thyssen or from whoever. And one way in a very abstract way to visualize it is, so you have your readable data, and you transform it into encrypted data. And you, as an owner, have the key, whereas no one else has the key. Now, within the encryption space, and this is rather drastic science here, you can do more math and get results from encrypted data, and then transform it back into results. Now, all of the math, all the intelligence gathering is happening in the encryption space. So basically, you don't know who supplied the data, but you know the information that it's coming out of. So basically, everything is happening behind closed doors, but you still are able to gain insights without seeing any business intelligence from anyone else. Okay, now if we go back to the initial thought that we're talking here about nesting, and one of the key elements about nesting is the data and the sharing of data and using the data, then there are a couple of conclusions to draw. One is, as Lars said, it's basically existing technologies, you just have to utilize it in a different way. You are using autonomous equipment and systems that are there. And the key point of nesting is that there's flexibility within it. So if you are producing multiple different variants of cars, you can easily do that with a nesting solution. And it requires hyperconnectivity, so it is essential, or Industry 4.0 approaches to that is essential. And we do have many levels of steering and process management tools, both from human side, but also from machine side as well. And this could bring up new business avenues, as Lars will explain.
Yes. With this system, we will also have some new business models to come. Using this autonomous technology combined with the technology we have today would be, I offer you technology as a service in the future. You can rent the technology from me. You don't have to install a conveyor line, use a lot of capex. You can rent it from me. Reduce your capex. I will rent it to you. I will do the maintenance of your equipment. You don't have to care about that. I will make sure that your factory is running. You will have a very increased flexibility, also flexibility in your equipment. If you tell me this month I need 10 robots, 100 AGVs, okay. And the next month you say, then I only need 6 robots and 60 AGVs. Okay, I'll rent it to you. And you will have an increased return on your investment. This only as one example of new business models. Thank you. If you have any questions, we are pleased to answer them. Thank you.
Thank you very much. Thank you very much, Lars and Frank. Inspiring, I would say. I would start with a question from my side. If I look into the automotive industry, you're heavily driven by takt time or cycle time.
Yes.
How would you see that been changing or been challenging with the nesting technology?
I see in the automotive industry, as also in other industries, that using autonomous AGVs, using nesting technology, not in all areas, but because it depends on the products, it depends on the company, if it suits them. But if someone needs a really individualized product, this is the absolute flexible way. There are different steps that you can start using it. Start just getting in, get the installed equipment out of your factory and get the flexible equipment in there, autonomous equipment. Then you can start with one area as a nesting. The rest could be fixed. If you go to automotive industry, if you have the mass production where you maybe don't have so much individualization, then you let parts of it go over traditional line and the rest in a hive. And the same is, you can transfer that to other industries. I like to use the automotive industry as an example because I'm very fascinated about cars and I worked a lot with automotive industry and I know a lot about their problems about individualization and flexibility in the factory. And the next step that you will have is, everyone talks about digital twins too. If you have a fixed line, the digital twin will not help you make a change with a switch. If you have these autonomous systems, you simulate it, you simulate the change with your switch, with your digital twin, then you pull the switch when you see it works, and the system will go this new way without you having to shut down or change anything.
Right. I see a couple of questions. We start.
So in the nesting technology, you can move the product to the equipment, but you can also move the equipment to the product.
Yes.
So, as experience, I know that every time I move a machine, even if they are flexible machines, modular machines,
Yes.
etc., it's a nightmare.
Yes.
Because we need to maintain 0.001 millimeter
Yes.
accuracy and repeatability.
Yes.
So how did you approach these, in my opinion, complex problems? Because you can move a machine, it's easy. Okay, you can move it every day, but then you have to assure a 0.00 and whatever millimeter of accuracy.
You're right, this is a problem, this will be a problem. There are solutions for that too. Take a robot. It needs the accuracy when it works. Put it on an AGV and it will not have this accuracy. But let this AGV run over to the next station and you have fixed holes, fixed points in the floor that you can fix this equipment to. And these are fixed point, these are calibrated point. And then you just have to do some slighter adjustments. So it drives over there, fix itself, and if you need to go to another area, it drives over to the next area, and fix itself again. This is theory. There are still a lot to do before we can really do this in real life. But there are a lot of institutes working on solutions, how you could do that now. I was at the AMRC 2 weeks ago and had some discussions, projects that they are working on at the moment, making these flexible floors of the factory of the future. So there will be solutions. There are no easy solution today.
There is a famous German, now Chinese, robot manufacturer that is, studying about putting robots on AGVs,
Yes,
etc.
I know them.
Self-adjustment, etc.
Yes, yes. So there are a lot of companies working on it, but you are right, it's difficult to do it today, but I'm convinced it will be possible in the future.
And I think, as you said, I mean, there will be steps and areas where you will start, proof. So you might start with a more lighter equipment than moving a press, for example.
I would be careful about that.
There was another question over there.
Thank you, first of all, for this impressive and good presentation. It's really good to see how we step by step go in this direction. You mentioned a lot of, let's say, improvements and potentials we can gain out of this kind of technology. So my question is, taking one of the last slides, maybe I have not captured everything, but if you put it in figures, in terms of lead time and improvement potentials, flexibility factors, what is your feeling from your experience?
That's a very difficult question because I haven't seen any factory that really have done all of this at the moment, and that will be very, it will depend on the product. If you have a mass product, you will probably not have much gain on this technology. If you have individualized products where every product is a single product, you will probably have high potentials within. It's difficult for me to make an estimation at the moment. We have had this question before and also thought about it, and what we are planning at the moment is to do a sort of digital simulation of this. So if you've talked to me in 1 year, maybe I can answer this question with figures, but I can't at the moment, sorry.
There's another question over here.
Do you have any concrete example you could share with us?
Concrete examples where we have done this, or no. I don't know any factory had really done this. I know there are several companies thinking about building this factory. We're also thinking about that. We're talking to some of our clients at the moment too. How could we realize some of this technology in their future factories? But no, I can't tell you any example how anyone had put up a really working factory in this way at the moment. This is an idea, this is a vision, and as I told you, we have to go step by step, and sometime in the future, and I think I will still see this, it will not be in that far future, we will have this kind of factories for individualized products, not for mass production.
And I would agree. I mean, that is one of the most challenging parts because everyone is looking into what innovative things can be done. The willingness to really start and do something, because it's sometimes difficult in doing that in a smaller scale. So there is some investment being required, and you really need to look visionary ahead of that. I had a similar situation where we're thinking about adaptive manufacturing in a press environment, for example, and took me roughly a year before someone said, yeah, let's do it. So, and I think you're in the same situation there on really getting that done. So it requires everyone here to think, well, what can be done? And I like that presentation really much on seeing the inspiring in there and think, how can that be enabled in your manufacturing environment? Where is a small space where you could try it? And then my suggestion is always do pilot. Try it out.
What I try to tell our clients very often is, hey guys, try to think different. If you think the way you always did, and you do everything the way you have always done it, you will never reach the bright future. You have to start thinking different. That means not do everything that everyone says that's the future. Think about, what's my future? What do I need to realize my future? And if this is a technology that your company or another company can use to build a better factory, a more efficient factory for them in the future, then use elements of it. If it's not, think different in other directions. And that's what it's all about. We have to think different, but we have to think about the future.
Last question over here.
Hans Gangelbar, I found it quite interesting. Thanks for the presentation. I guess it's like Taichi Ono mentioned 60 years ago, it's all about need, chapter 1. And it reminds me on the nested modularity, which Taichi Ono was proclaiming 60 years ago, basically. The interesting thing, though, is we have a completely different set of tools and technology on hand. And I guess modularity is the key word, where you have stable processes, common processes. You won't go to that because it's not going to be affordable. Yes. But where you have the variations in your products and the complexity, and you have this swarms, basically, or these cells where you can autonomous deal with changes within the cell, makes fully sense. The key, I guess, will be how we're going to deal with the interfaces between the cells and between the modules, because we have a lot of standards in the industry. It would be nice to reduce those standards, that everyone can talk to everyone.
Yes.
If we get a further step ahead in this regard, I guess nested modularity will become a standard within our industry in a very, very short period of time.
Let me just quickly jump into there. I absolutely agree. The essential part is getting everyone talking to each other, because hyperconnectivity is the only way to get the data you need and then build on that. And this is where open platforms from the German Bundesministerium come into play. So a standard is one way, but also having everyone accessible to the platform is essential. Yeah.
All right. Thank you very much again for the presentation.
Thank
Big
you.
applause.